Well, let's wait a little bit until others join, and then we'll start. Okay, so let's start. Hello everyone. Today we're going to continue talking about the data structures and collections. And so we will finish the theory part and then we'll go to the practical part. So the practical part, here we'll have two tasks to be completed together, during the classes, and then you will have also two tasks to be your home as your home tasks. And yeah, so first task we'll do together, together in class, and second one will be individually, to be done by you with my help, and then we will go through it. Okay, so that's the plan. And yeah, so just before we continue, so let's have a quick look on what we were talking about last time. So last time we started talking about the data structures and the collections. So basically we were talking about the way how the data can be stored, how the data can be managed, and basically how the data can be brought. So that's also a really important point. And yeah, so first of all we talked about the objects, since we know that we have the feature of object-oriented programming. That's a very large feature. We can really use it in many different ways. So then it helps us to work with the objects in many different ways. So just again, before we start, so let's shortly remember what kind of features do we have with object-oriented programming we talked so far. So first of all, the main thing that we have the objects which can be created from the classes. It means that each object has its own reference, and the actual value of this object is, of the object type variable is the reference of the object. Yeah, so it means that from one class we can create many different objects with the same type, with the same characteristics. So, and that's a really important point, what we can use. So it means that one class can be used as a template, as the type, and then we create multiple objects, and then they can be used in the program execution. So that's the first point. We have the objects created from the class. So each object has, the objects may have the attributes, basically the parameters which describe the properties of the corresponding object unit, and then we have the methods and the functions, methods which describe the behavior can be done on the corresponding object. So again, that's not only like the behavior what object does, but also what can the actions what can be done where the object is involved, like to make some changes to the object, maybe also to involve the object in some actions, and so on. So that's the point. And yeah, so in fact we have this encapsulation principle for object-oriented programming, and this basically helps us, also it helps us wrapping the data inside this class, inside the object. So it means that every different object, like every object, is the place where the data can be stored, and basically the class template, the object itself, the methods can help us to manage the data, to control the data on this in this object, one or another object. Yeah, so that's the point, and so that is how we basically proceed. Also, please remember again what I just mentioned, but I want to repeat it, that each object has its own reference, so it means that this is specific unique pointer to the specific object. So it means that we can store, so in many different places in the code, we can store, as the variable, inside the variable we can store the reference of the corresponding object, which then can be used to actually access this object or to transform it from one place to another. So we talked about one such data structure where we can use it, and the collection structure we can use it. But first of all, let's maybe go quickly go through all the main collection types we come through. So first again, what is a collection? Collection, it simply means this is the class type, the class. There are lots of different classes, but all of them actually inherit. We'll talk about inheritance a little bit later in this course, about inheritance. But all the collection classes, they inherit collection class. So what does it mean? It means that all these classes are actually considered as collections, and all these classes are considered as collections, and the main purpose of them is to store the data with where the size is actually it can be unlimited. Yeah, so it means that basically the place where we store the elements, like the arrays. But comparing to the arrays, we have some restrictions. Yeah, the main restriction we know is that the length of the array is limited. Yeah, it can only be defined once for each object, and then we cannot change it during the execution of the code. Okay. Comparing to collections, where we can, the logic is created in the way that we can actually do it. Yeah, so that's the point. What we talked about. Of course, we still can use arrays. Yeah, but you all know the restrictions what we have. But then we started talking about actual collection classes. So first one, what we talked about is stack structure. Again, what's the difference between collection classes? Basically, each collection class has its own unique, let's say, purpose and the way how the data is managed. For example, first one, what we talked about is stack. So the stack is basically the structure of data storage and data managing in the way that we have the elements, and each element actually goes on the top of the previous element. At the end, so not at the end, but at the point when we want to fetch the element from the collection, to actually get it from the collection, then the first element what goes out of the collection is the last element added. Yeah, so just imagine the collection of chairs, and then of course first you add the bottom chair, then you add more and more, and at the end you add the last one. Then when you transport it to another place, you take the last chair as the first one. Yeah, so that is the structure last in, first out. And this is how basically the data is managed in stack collection. Yeah, since these all are the classes, so as I said, we have the operations. on the collections, and for stack we have operation push. It means that we add a new element to the collection, and then we have pop, which means that we actually delete the element, and in this case we'll push the element to the last position, but also delete it from the last position as well. Yeah, so that is what was mentioned there. Then the second collection type is queue. So queue works the same way as just a simple queue in real life works. So it means that you, for example, can just go buying the tickets or something like that. So we have queue, and again, as it normally happens, the first one who is in queue, he or she gets the tickets. So just if you're buying the tickets. So yeah, the same as in the data structure. So it means that we add the elements one by one. Then when we actually get the elements, delete the elements out from the collection, then actually the first element is deleted. The first element every time is deleted. So that's the point. And yeah, so just like a simple queue in real life. If you have any questions, you can ask. But then we also talk about quite specific data collection type, which is linked list. I mean, it is specific from the implementation point of view. And as we discussed last time, basically we also created some kind of implementation of linked list type. So that was I used the officer class, and we actually implemented some kind of linked list structure. So basically it means that for each what was it? I don't remember. That was this one or district. Oh no, yeah, that was this one. So yeah, the idea here is that for each object, we actually have, again, the linkage can be stored inside the object. In theory, the linkage can also be stored outside the object, but it depends. That's not so important. The key idea is that for each object, we have the linkage to the next object. So in this case, we basically link the objects, all the objects, and that is how the chain of the objects is created, and that is how we actually see the collection of the objects. So again, here I want to remind you what I said some minutes ago, that the objects actually store the references. The references. One moment. Yeah. So the objects actually, they have the references. So it means, again, the reference means that that's the value which points us to the corresponding object. So the same is what we have here. For each object, as I said, we can actually simply have the variable. Again, remember that the classes, the object types, are also the data types we can use. Yeah, so we can use them, and then it means that one object, officer object in this case, can store the variable which points to the object, or to the officer, to another officer. So in theory, this officer can also be the same officer, so it means that the variable, the class of the object, let's say, one corresponding officer may have the same officer stored here. So that would be like something like this, yeah. It means that the officer stored under officer is actually the same officer. That's also possible, since this is just simply the variable. In variable, inside the variable, we can store everything we want. Yeah, any values. So the value again can in theory point to the object itself. Yeah? But in this case, we don't use it. In this case, we point using these variables. We point to another officer, which is actually the next officer in our chain. Yeah? In this case, I created the variables previous officer and next officer. So and here it basically means that next, like if we have one corresponding object, then the next officer, the next object will actually be the variable which placed under the variable which stores the next element. Yeah, and I also, just to make it easier for me, I also created the pointer to the previous officer and to actually point to the previous object. And that's the way how linked list works like. Yeah, the idea is that each object stores in some way, it stores the reference to the next object. Yeah. So that's the point, and that's how I actually create the link. We can create the linked list again without any arrays, without any specific specific data storages, and just simply one object points to another. Yeah. So here we have some, comparing to other lists, we have some advantages and disadvantages. So the first advantage again is that the size of the we do not need to change some kind of size of the array, for example. In this case, the size is not needed, since we basically have just two slots for the variables, two slots of the variables for each object in this chain. So we simply just need to fill the value there. So yeah, that's the first thing, the first advantage. Second advantage again is insertion. So insertion and deletion of the elements. So comparing to the arrays, for example, for the array to add new element, we actually then need to create new array, copy all the elements from original array, and then add a new element. In this case, what we just simply need, we need to change the references stored under the specific object, just stored at the place where we need to, before the place where we need to want to add our new element. So in this case, it does not require more memory to be taken, and it also does not require time to create a new object. Yeah, in this case, everything will be stored under one place. Yeah, but the disadvantages would be that if we need to search for just not search, but to access one specific element, say we want to access the third element, then in this case we'll need to go through all the elements from the beginning and then to count them that way. Yeah, so it takes more time comparing to simple array where we can just simply access the element by index. Here, in this case, we need to go through all the elements. So that's a disadvantage. Yeah, so the updates, not the updates, but the counting takes more time here. Yeah, so that's the point. If you have any questions, so that was the cut from the previous time. If you have any questions, please ask if something maybe is not clear for you. And yeah, now we can continue. So first of all, just to remind you how the arrays are stored in the memory. So basically the idea is that there is the allocation, the place in the memory where we can actually so when we want to create, for example, the array 1/6 of characters, then we simply allocate 6 slots in the memory they are stored in the sequential way. Yeah, so and then we just simply have the link to the, so again, each, in fact, yeah, so these are also the objects, but I mean the arrays are the objects as well, and so yeah, then each element has specific reference in the memory. So and then actually the reference, the link to each position of the array is actually changing by 1. So the first element has the reference ID 0, the next one has 1, then 2, 3, 4, and 5, and so on. Just in case the array has more than 6 elements. And basically, yeah, that is why again the arrays start at 0, because we actually start from the beginning, yeah, without any addition. Yes, what means that the second element we need to add 1. That's why it's 1. And the first one is 0. Yeah? So that's actually the way why also the arrays cannot, the size of the arrays cannot be changed, because the idea is that the size then here is fixed in the memory, and if we want to change it, then actually we cannot really allocate another place of memory there. So just in this case, we need to create a new array and then allocate the array object, and then we need to allocate the memory there. So that's the point. But yeah, linked lists actually stored in the way that yeah, they have random allocation, and so the arrays have one specific directed and sequential allocation in memory. Linked lists do not have any specific allocations. They actually have random allocation, because the idea is that there is one object created somewhere, there is another object created somewhere, there is one more object created somewhere. Then what do they have? The first object actually points to the next object, then the next object points to the next object, and so on. And the last object actually points to nowhere, because it has no next element. So that's also the point from the memory perspective. So do you have any questions about it? Okay. And if not, we can move on. Yeah. So then also traversing operation. Yeah, basically how to navigate to a node. In this case, random access is not possible. So, and that's why we actually need to navigate. So if you want to navigate, we need to go through all the nodes, to navigate to one exact node we are looking for. In this case, we can also use while loop. We can use recursion. In this case, that will be the same. Yeah. But yeah, so the idea is that we go to next. So that will be like we have first node, the first object. That will be the heat object. Then we check if the next one is not null. Then means that we assign next one to node. Then we go next again. At the next operation, the previous node, actually the node what was previously next. In the next operation, it will become the current one, and then we check next, which is actually next. Yeah, so then to go through all the nodes, we need to then for each node we need to access next, and so on. Yeah, so yeah, just in case we want to use it. Yeah, any questions? Yeah, I mean on practice again. So here we just had the rough implementation of the linked list. On practice, so if I'm not mistaken, the idea is that we have like some kind of node class which actually stores one object and the reference to the next object. So, and then actually means that for each class we actually have duplicated object which is used to store the necessary information about the next object. I mean, just simply the reference of the next object in the list. But from our perspective, that's not so important. The concept is the same I described last time. So just basically the idea is that we start with one node, then the next one we are here, then the next one we are here, next one not next, and at this point node is this one, and so on. Yeah, so just basically we just do such type of the value assigning. And at the end we will finish at no, which means that we've gone through all the elements in the list. Okay, then the next operation is appending the node. So to append, there's the difference when we appending the node and when we inserting the node. So append usually means that we add at the end of the list. In this case, the idea is quite simple. Just add a new node after 20 object. That would actually mean that the value of the pointer will be the reference of the node we are adding. And then the node we are adding, it will have the pointer null to the next element. So then the algorithm to append the node will be that we create a new node. Again, in this case, this is, the actual structure how the linked lists are used is a little bit, again, it is more complicated than what I had here, because here I just did everything in one class, in one officer class on practice. It is more usual than we have multiple classes there. Not multiple, but actually two classes. So we have the one class, our main object class, and then we actually have the node class, which then simply stores the officer object and then the pointer to the next officer. So basically this logic with these attributes and these methods, these two methods, actually more methods. These methods what are related to them, basically created for the linked list, they are all stored under special node class, which then actually stores the object itself and the pointer to the next one. So then the idea, the algorithm is that the node is created. So now again, here what we have, the node is 20 plus pointer. So that's what the node has. The object has only 20. So we actually add pointer there. Pointer variable is placed in addition, and also the methods what actually allow us to do the operations there. So that's the point. That's the point. So first of all, to append we need to create the node. Then the next step is that we make the next pointer null. So it means that actually the last element points to nothing, because that's the last element we add. So again, we add, and then it will point to nothing. So then that will be that we traverse to the last node. So we navigate to the last node. Then we point last nodes next to new node. So then the idea is to add. So we have the object, we prepare the node, then we navigate through all the nodes here, we go here, we find the last node which actually points to null, then the pointer now will point to the node we created here, and then we append new element. So any questions about appending? In this case that's quite similar what we implemented. Okay, no questions, then we move on. So that is how it looks like. So what happens? We create new node. We make the pointer null. Means it points to nothing. We go through all the nodes. We navigate to the last one. Then the pointer now will point to that object, that node, and that's it. Yeah, so as I said, nodes have two parts, the link and the data. Again, the link is the link to the next object, and the data is the actual object. In our case, we basically stored everything here inside one officer class, but said in normal case, middle case, there will be another class, a node class, which actually stores node object, which actually stores them, the elements there. Not the elements, but the object itself and the pointer to the next object. Okay, yeah. The operations, what we can do, we can go through all the elements. Yeah, we can append the node. We can prepend the node. Yeah, insert the node at some point. Yeah, after some element or in between the elements. Yeah, insert the node and the corresponding position, and also delete node. So that would be this way. And so we create a new node, then we search for the place where we want to add, and then we simply change the references there. Okay, do you have any questions so far? Okay. And then if not, yeah, so this is actually singly linked list. It's called. And in fact, there is, yeah, this is what was single linked list. In fact, so we actually implemented last time that was doubly linked list. So it stores the element, it stores the next element, and it also stores the previous element. Yeah, so that's the difference. In fact, we can deal with singly linked list, but for singly linked list, what's the advantage? The advantage is that we don't need to store the previous element, so we have the advantage from the memory perspective. It takes less memory, but what's the disadvantage is compared to doubly linked list is that it takes more time to actually navigate to the previous element. Yeah, to actually navigate to the previous element. Because otherwise, yeah, if we have only single, if we have single linked list, then we can move forward only. If we have double linked list, we can also move back as well if needed. So yeah, that's the advantage. And there is also circular linked list. It basically means that it is actually also singly linked list, but the idea is that the last element points to the first element. So in this case, we actually have this cycle, and the operation of going through all the elements will actually be endless. Yeah. But such list can also be used, can also be created. But yeah, so that's, in this case, it's quite similar to singly linked list. Again, the only difference is that the last element is not the last not element, but the last link is not null. It simply points to the first one. Do you have any questions? Okay, then if not, let's move on. Yeah, so the summary of data structures. So there are basic abstract data structures, the sets, the lists, trees, and graphs. So sets, we'll talk about the difference between sets and lists. Then there are actually trees. The trees have the for the trees there's such a thing that they actually work as the tables normally work. So they have the keys and the values mapped to the keys. The keys must be unique inside the tree data structure, and then values can have duplicates there. And the graphs. So the graphs are the simple representation of graphs in mathematics. What we have? So the graphs with the edges and vertices. So basically the vertices, the edges are those who store two edges, two vertices. Yeah. And that can be orientated graph and disorientated graph. So disorientated graph is the graph which has no direction. So it means that we just simply have edge from one vertex to another, and vice versa. In this case, there is no direction for the edges, but the directed graph is the graph which actually has the direction. So it means that if we have the edge in between two vertices, let's say vertex A and vertex B, then it is also important from which vertex to which the edge is directed. And graph, actually, this is what can also be represented in a data structure. There will be the task, which the assignment where the graphs are required. And yeah, so these are the basic abstract types what we have. Then there's also a basic concrete data structure, so linked lists and variants. So this is what we just talked about, and also some variants of it. For the trees, there are also different variants. Like what are the trees? Are the tree set also? Tree set, tree map, for example. Yeah. Then the key properties. So we'll examine them. And yeah, we'll also discuss usage of solving problems, search, sort, selection. So yeah, for the sets and multi-sets. So for the sets we have common operations, like for the fixed sets we have operations. So these are also the collections. The collection type, more abstract, I mean. We don't talk about specific collection specific set types. But yeah, so what kind of set structures we have? First of all, we have fixed sets, and we also have dynamic sets. So we'll talk about the difference between them a little bit later. Just about some methods they have. Fixed sets, they have method contains to search for exact element. Then there we can check the size. We can check if the collection is empty or not. Then we can also enumerate the elements. And for dynamic sets, we have the operations add and remove. Yeah, so basically add or remove the elements there. So then we can also have such operations like intersection to check what are the elements. Let's say that we have two sets, two collections, and then we want to find out what are the elements the same in one and another collection. In this case, we can use intersection method to find out this set, and then the union to actually unify the collection. So it means that just simply to combine the elements from one and from both collections into one. The subset, to then actually get this corresponding subset of the set. and these can and probably should be implemented statically outside the class. Because these are actually the methods where we involve two collections, two sets, and that's more likely that these are static methods. So then the list, just in general, what are the lists? So let's go through some common queries. So we can enumerate, we can check the number of items in the list, we can return element at corresponding index I we provide, and also search for an item in the list. We have to check if the item exists in the list or it does not exist. So such check is quite popular, especially if we do some kind of data check. We work with data, so this method is relevant there. And common comments. So again, queries is that we get something, we want to check something, we want to get the element, and for the common comments, what actually these are the methods. What make the changes on the collection is they are to add element, so to add a new element to the collection, to set the list, to set element at corresponding position I, also to remove element, and insert. Also we can insert element for index I we provide. So then there are concrete implementations for set and lists. So for set, what might you use to implement a concrete set? We'll talk about them, about concrete implementations, because again, set and list, these are the abstract, the abstractions. The abstractions, we'll talk about the abstract classes a little bit later. But the idea is that in fact there is no such classes like the actual classes you can use, like list and set. On practice, we should have more concrete classes, more concrete implementations, which actually implement these two patterns. So for example, for lists, we already used array lists, and we already used linked list. So these are complete implementations of the list class. And then we'll also talk about sets a little bit later. And we'll also talk about what are the advantages and disadvantages of different set types. Then there are also the trees. So what the trees are. In fact, a tree is collection of nodes and directed edges satisfying the following properties. So first of all, there is no one specially assigned node called from the root which has no edges pointing to it. Maybe I can also share the tree data structure. So then every node except the root has exactly one edge pointing to it, and there is a unique path from the root to each node. So in this case, that would be simply such data structure. In fact, the data is stored this way, and what we can actually see here. So in fact, the data is stored in some kind of numerical way. And basically, tree data structure is some kind of sorted data set. And actually, it's this data set which should always be sorted. So in this case, maybe let's shortly talk about data structures. Actually like this topic a little bit. So, not only this topic, but this topic, from my point of view, it's quite interesting. So, let's then talk about, again, data structure. What does it mean? And especially when we talk about different data types in programming, for example, in C#. when we have the array, what are the restrictions there? Just no restrictions. I mean, there are restrictions from the size point of view, array size, but there are no restrictions from the point of view how do we store the data there. So we just can simply put any object, any value at each position we want. So and basically we can proceed there as we want. The data will be stored just in a way how we pass it to the array. However, that's not for all the data type. For example, we have let's say the binary tree. And so in fact such data storage can also be implemented. And in fact, what does the binary tree do? So again, we can enumerate all the possible data. If it's string, most usual these are the strings and the numbers. So let's maybe start with the numbers. And yes, in this case we can just simply understand, we can imagine it in the way that we also have the strings and something like that. So for the binary tree, how basically the data is stored? The data is stored in the way that we have the root element, which should be the smallest one. Then what happens? Then for all the elements, we have the case. Let's maybe find binary tree. So let's find some kind of yeah, so maybe this example, binary search tree first. Or maybe this one. This is I guess this is maybe more interesting. Actually, there are different implementations there. Yeah, okay, maybe this one. So first of all, we have the root element. We start with the root element and then we add more elements there. So first of all, what's the point? The point here is that since this is binary tree, it means that for each node we can add we can have two elements only, and basically how the elements are added there. So let's say that we have the collection which stores the values 6, 9, 14, 35, 30, 26, 20, 12, 8, 11, and 15. So let's say that the first element we add is 15. So then we make it as the root element, and what happens next? We add the next element. So the next element, let's say we add 11. So is 11 less than 15 or it's greater than 15? It's less than 15, then it goes to the left side. Yeah. Then it goes to the left side, and the next element, yes, then we check if, so let's say that we add 8. So then we check, is 8 less than 15? It's less than 15. Is it less than 11? Yes, then goes to the right. Then let's say we add 12. Then again, what we check? We check if 12 is less than 15. That's correct. It goes to 11. Is 12 greater than 11 or less than 11? It's greater than 11. Then it goes to the right side. Since it's greater. So then we have such tree. Then let's say we add 26. So here we check, is 26 greater than 15? Yes, it is. Then it goes to the right side. Then we add 9. Again, less than 15. It's less than 11. Then it goes here. It's greater than 8. Goes to the right side. So here the 9 is placed. Then we add 14. 14 is less than 11, that's correct. Then 14 is greater than 11, that's correct. 14 is greater than 12, it goes here. Then we add, let's say, 9. So 9, I guess. Did we add 9? I don't remember. Let's say we add, so it goes in this path. Then we add 30. Is 30 greater than 26? Yes, then it goes here. Then we add, let's say, 35. Then again we check, it goes right. So then 20 greater than 15, less than 26, so it goes here. And at the end, when we add all the elements, we have this binary tree. So why am I saying this? Because on practice, in fact, the trees, the implementation of the trees is considered as the collection which will always have sorted elements. Not actually sorted, but basically it means that we cannot really add the element in any place we want. Yeah, so everything actually here will be sorted in the way that we have, let's say, so it will be like we start. How can we actually implement the sorting here? It's quite easy. We need to go from left, so it means that we go from left to top to right. Then we go to top to right, then to left, and then to right. Yeah. In this case, we don't have anything on the left, then we go to right. Then from here again, we go to top, and then I go here, 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 here. And this, this pattern will always be correct. This is not binary search tree. Yeah, for example, from here again, we go here, here, here. Then we go here, here, here. And this will always be correct pattern. So in this case, actually, we see this data structure as the sorted tree. Where was the tree? Which one was it? This one, I guess. Yeah. So that's the point. And what's so in this case we cannot add the element to the position we actually want. In this case, then to add the element we would need to rearrange the elements, so actually to restructure this tree if we want to add new element. But what's the advantage? The advantage is actually when we want to read the element here. Yeah. So let's say that you want to search for the element, let's say element 8. Yeah. So in the usual collection, just let's say that's the array or array list or linked list, that would take a maximum n steps. Yeah, so the n is the size of the collection. Yeah, so in the worst case, you would need to go through all the elements. When we talk about sorted data trees or sorted collections, like in this case we talk about or binary tree, in this case it takes much more less time. Why? Because in this case we can implement the following pattern. So let's say we're searching for, this is at 9, for example. Then what we can see? We can see that we start from the top. Then we see is 9 less than 15? Yes, we go this path, this way. Then is 9 less than 11? Yes, we go this way. Is 9 less or greater than 8? It's greater. We are here, and here we found the element. So in this case, we take it takes 1, 2, 3, 4 steps. And in general, if we have such tree, then the number of the steps will not exceed the number of the levels heights we have here. So here we have level, let's say level 1, and level 2, level 3, level 4, or we can also start at 0, so if we level 0, level 1, level 2, and level 3. Yes, so it will not take more than 4 steps in this case. In all the cases, what's the data we have. Yeah, so that's the advantage, and this is how the tree structure looks like. Yeah, so there's no one specially designed node called there's one, yeah, special design root element. And yeah, the question from Maria, yeah, that's actually a good question. Is it possible to store two same elements? Yes, it is possible, but they will actually, yeah, in this case that's the good question, if the element will be placed on the right or the left side, actually I guess there's no difference if we put it to the right or the left side. But yeah, we definitely can store. I don't remember again if it's the right or the left side, but I guess we can select it. Yeah, I'm not 100% sure if it's the right or left side, but I guess we can basically, it does not change the pattern, because if we simply have, let's say, 12 here, then 12 can actually go, actually the difference is that if 12 goes to the left side, then in this case 14 will be here. If 12 goes to the right side, then that would be like one more level, because that will be 12, 12, and 14. That will be the next level. Yeah. So, but yeah, that's definitely possible to store two elements there. Yeah. Yeah, that's about the trees. Has that one edge pointing to it. Yeah, that's fine. There's a unique path from the root to each node. So this is also true. So yeah, and here we have basic tree concept. So node, so that's user-defined data structure that contains pointers to data and pointers to other nodes. Yeah, so first there is root node, from where the tree starts parent, so means that for each node we have a parent node, and child node, what actually goes down, yeah, that would be the child. Leaf is actually node without any descendants, and degree, actually number of direct children subtree has. So these are main terms about trees. And yeah, so height, so that's the number of edges on the longest path from the root to leaf. Yeah. So in this case we'll have height going to be 1, 2, 3, 4. Yeah, so one edge, second edge, third edge, and fourth edge. So that's the longest path, and that's the height we have here. Yeah. So the height is 4. The level, so the root is at level 0, then we have level 1, have level 2, level 3, and so on. Yeah. So just in case you have any questions, please let me know. So then there are rooted trees. So if an edge goes from node A to node B, then it's called parent of B, and B is called child of A. Yeah. This is what I mentioned. That's quite makes sense. Then children of the same parent are called siblings. Here, just like in real life. Yeah, so these two are siblings, for example. These two are siblings as well. These two are siblings as well. Yeah, if there is a path from A to B, then it's called an ancestor of B, and B is called a descendant of A. So actually means that if we go from A to some kind of node, so there's the path, and F is descendant of A, and A is ancestor of B. Yeah, and a node with all of its descendants is called subtree. Okay, so in this case, if we start at, in this case we can have node, let's say D, F, G, H, then that would be the subtree of whole tree. That's the point. Then if node has no chain, then it's called leaf of tree, what I said. And if a node has no parent, then it's the root of a tree. Basically, the starting node is called the root node. Yeah, so here's the example. As I said, A is the root, and D, E, G, H, J, and K, they are the leaves. Yeah, B is parent of D, E, F, yeah, and so on. Dimensions. Do you have any questions here? If there are no questions, then maybe let's have 10 minutes break, and then we will move to the binary trees. So okay, let's continue. So yeah, and yeah, so now we go to the binary tree structure. So so binary tree means that's the tree where each node has no more than 2 children. So basically what we just talked about, that was these were the binary trees. So each node has maximum of two childs. Child to left and child to right. And yeah, so then we talk about, I just mentioned the tree I showed here, that's the binary search tree. And so again, as it stands from the name, the main purpose of it to search the elements there. Search the elements there, and the thing is that, so that's the tree in which each node has a value satisfying the following properties. So first of all, all the values on the left side are great, are like in this case, basically it doesn't matter on the left or the right. We can define the way that all the values on the left are smaller or all the values on the right. So basically from the implementation point of view, not from the implementation, but from the practical point of view, there are no differences here. But the idea is that on one side, like in this case we select the left side, all the values must be less than the values on the right side. Yeah? So for example, this can be applied to all the numerical values and numbers, and this can also be applied to the texts, to the strings, because the idea is that like as you know, for each character we have one unique Unicode, which can be expressed actually by byte, which can be expressed in the numerical way. So in this case, we can just simply sort the strings in alphabetical order. So in this case, we can just simply say that the value Brenda is, the string value is less than the value John, because B comes second in the alphabet, but John comes after that. Yeah. So in this case, John is definitely great. It's definitely greater value than Brenda. Yeah. And in binary tree, that's the idea. All the elements left should be less than the elements on the right. Yeah. In other words, can we put non-perishable data into a tree? We'll study and research this a little bit later. But yeah, I explained the concept of them. Yeah, so we can. Yeah. So then we move on. Yeah. So binary tree is full. It has no missing nodes. Yeah. So it means that at least one node will have, like, there's no gaps in between. And yeah, so the roots subtrees are full binary trees of height h-1. Yeah, so it means that for each subtree, it will also be the subtree will also be the binary tree, binary search tree. So if not empty, each node has 2 children, yeah, except at level h, which have no children. Yeah, and it contains a total of 2 h plus 1 minus 1 nodes. Yeah, in fact, if like we have the case, then like in this case, yeah, we have let's say if we add, for example, we want to add node 56, then in this case we will need to rearrange this node, because simply that would be that 56 in theory should go here, But in this case, what will happen? We would need to rearrange this tree. So in this case, that would look like, I cannot rearrange it here, but if we add, for example, 56, then this will be added there. But since we have like we have the situation when we have two empty, like not empty, but not the last node has only one element. In this case, that will be that 55 will have only one child. But the thing is that it is not, like if we add 56, it's not the last node. Then in this case, that will not be correct. So what should be done? Once we add 56, we should then move 55 here, then 34 will be moved to the left, and then 56 will be moved to the right. In this case, it will satisfy the binary search tree, and everything will be fine. Yeah, so maybe I can also, just to make it easier, I can throw it online. There are some visualization. So let's say that we insert 45, so that we go to the root. Then let's say we add 98. Then let's say we add 30. Yeah, I can so share this link with you so you can try it by yourself. Yeah, so then we have this term, then we have 20. 20 should go then here, yeah, because it's faster than 45, it's faster than 30, it goes here. Yeah. But what's the thing? This is what I just said. If we have 10, then it won't actually, it will go after 20, but then the tree will need to be rearranged. In this case, 20 will go here, and 30 will go here, and 10 will go here. Okay, so it will go here, 20 go here, and 10 go here. Okay, so here, oh, okay, it's not rearranged, but okay, in this case it does not show, but it should be rearranged. Let's, like in this case. So let's try here. 20. Let's add 10. No, that's something different. Oh, element. That's something strange. Okay, let's name this one. But okay, yeah, there are actually different implementations of this, but in general way, this should be rearranged just according to the. Yeah, in some structures it is not needed. Like if we add 10, then in some structures we can keep it like this, but normally then this should be rearranged, and then that would look like the 20 will go to the top, and then 30 will go to the right side. But again, it depends. It depends. Sometimes it can also be in this way. It depends on the data implementation, data structure implementation for the binary tree. Yeah, in this case, it looks fine. Yeah. In this case, yeah, that's correct. Yeah, so binary tree is full. It has no missing nodes. So binary tree, it's complete if it is full down to level h-1, and level h is going from left to right. So that's basically what I already mentioned. Then, oh yeah, actually there's balanced tree. If the difference in height between any nodes, left and right subtree is less than 1. Yeah, so in this case that would be like this. And a full binary tree is also complete. A complete binary tree is not always full. And full and complete binary trees are also balanced, and balanced binary trees are not always full or complete. But again, that's too many theory. Yeah, so just again, maybe a short note about what's balanced and what's unbalanced tree. So that's complete and balanced, but this one is not balanced. Why it is not balanced? Because this one has one node only. So it has one node only, but it's not the last tree. So in this case, that would be that how we can balance it. This should go down, and this should go to the top. So then, but again, the idea is that this is missed. I mean, not missed, but this has only one child. Yeah, so basically how it can be implemented. So yeah, we didn't talk about structures before, but so here you can see that the structures are used. So yeah, in fact, there can be the class binary tree, then there would be the pointer to the root node, and yeah, so for each node there's the left child and right child, can also be implemented as a part of this node. Whew. Yeah. So. Then there is also the table-based representation. So for the table-based representation, the idea is that so instead of using actual pointers, the left and right child node, we use indexes into an array of nodes representing the binary tree. So yeah, in this case, there is a free use of index to the first position in the array that is available for the new entry. And yeah, then we can use left or right child indexes to indicate additional available positions. So, and yeah, in this case, it makes the free list. So here we can actually check. So here we have Jane, then Jane has left child and right child, so right child points to second index, so that means that points to Tom, and left child points to the first index, which then points to Bob. Yeah, so basically using the indexes, we can point to the corresponding item in the array. And we use -1 when we just simply have no child on left and right. So, and so on. Okay. And then if we add more, then it will actually take place on the next element, but and yeah, if we want to delete, then it will just simply be removed. Okay. So that's the point. So just you actually have lots of theory about trees, but yeah, let's maybe quickly go through. That's maybe just more important from the theory point of view. From the practical point of view, we will just simply use the collections, the classes which are already implemented. But yeah, so there's also a little bit about level ordering. So let's say that there is the number between 1 and the actual size of nodes assigned to the corresponding elements. So each element has the index And yeah, so then we can also have the array-based implementation where we actually store each node as the index. Then we can actually place the corresponding nodes into the exact places in the array. In fact, on practice, that is possible, and basically where such elements of the trees are stored, they are actually stored, in most cases, they are stored specifically in the corresponding places in the arrays. So in fact, again, comparing to the linked list where we do not use the arrays, for the tree structures, we do use the arrays. And there is specific element storage. How they are represented, yeah, you can take a look from this picture. Maybe I'll not really go through. There are actually the formulas which are used to calculate the corresponding index of the array to then understand at which position the element in the tree is located. But yeah, there are actually the formulas. There is actually the representation. Maybe I won't go deep now, but some elements may be null, which basically means that there is no one or another child. But yeah, it is possible. It's possible, and on practice, the trees are represented using the arrays. So that's also the point to think about. Okay, do you have any questions? Okay, so if no questions, yeah, so basically what's the advantages? Yeah, as I said, in fact here it is easy also to go through, but again, here we have the formulas. The formulas at which corresponding position in the array the elements are stored. Yeah, so the parent will be stored at the index divided by 2 position, so that will actually be on the top of the child elements stored, and so on. Yeah, then the drawback of array-based trees, simply we have 3 nodes, but then you would lose 2 in power of h plus 1 minus 1 array of cells. However, if the array is just numbers of pointers, we should not have a huge concern, since we just simply have the array to go through the elements there, and not go through, but to access the corresponding element, then you can just simply point to the index, and that's it. So then we can go through the traversal of the elements. So usually first we visit the roof, or the root, the root, and then we can go through just one subtree or another subtree. Again, this is based on the formulas. In this case, maybe I won't go deep here, so just in case you want to go through, you can explore it by yourself. So I guess we have too many slides here, and so on practice you'll see that we won't go really deep into the data structures in general, just for you to understand. That we simply use the arrays, and we can, in fact, yeah, we can represent the data using the array formula. Yes, so for example, here we can see the array. Like if we have some kind of string here, it can be represented in the binary tree. Yeah, so we have the first element, which will definitely go to the top. Then we have the element C, which is less than F, so it goes to the left. Then we have element J, which should be this one, then element A, this one, D, this one, H, this one, K, here, and I, there, yeah. So the first element goes to the top, then the next two are the childs, then next to are childs of the first child of the left child. So left elements will go first, and then right elements will go next. Yeah, so childs, left childs here and right childs there, and the last element, of course, will be the last one. Yeah, there's also the recursive binary tree. Maybe for now, let's skip the binary trees, because there are basically lots of formulas there. And so just to not go deep in the theory of binary tree, basically I describe the most important cases already. And yeah, so then let's switch to the graphs again without without lots of theory there. So first of all, again, for the graph, what we have the vertices and we have the edges. Again, why do we need the graphs? And graphs are the representation of the graphs is quite important when we talk about the data structures in general. I mean, it can be any data. Usually these are essentially XML. Then again, here we have the levels. We have the levels, we have the sub-level of the level, and so on. So we have this some kind of data structure where we need to have the navigation. And from one, and yeah, there we also have the direction there. And as I said, as I mentioned many times, what's the main usage of the recursion? So the main usage there is that, as I said, we would need to go through some kind of path, yeah, and usually we can describe such path using graph. So then there are some properties, and it can be undirected graph, so where it means that we don't care about the direction between the vertices and the edges. And then we have directed graph, where we do have such direction in between the vertices in one edge. Then there's also weighted graph, where we can add the weights to each edge. And then there are some properties there as well. We will maybe shortly talk about them. So then how the graphs can be represented, and so weighted graphs, and so let's start maybe with undirected graphs. So we normally represent them in the matrices. Yeah, so this is basically where we can use two-dimensional arrays. Yeah, so again, the matrices from mathematics they can be represented in the arrays. So we have two-dimensional arrays here. Yeah, for example, if we want to represent the graph, yeah, we call it agency matrix. We can also use the list. It doesn't matter for us at this point, but yeah, these are two equivalent representations. So for matrices, if we have non-directed graph, then we will have symmetric matrix, where actually we'll have the columns and the rows, not the columns and the rows, where there we will have the vertices. Yeah, and basically, if we have value 1, then it means that there is the edge between 1 and 2, and between the vertices. So again, here we have the vertices 1, 2, 3, 4, and here we have the same vertices. So the columns and the rows will be the same. I mean, the values there. The idea is that the values there can be different. That can be 1 or 0. 0 means there is no connection between the corresponding vertices. Like here we can check there is no connection between 2 and 4. Yeah, so this one will be 0. Here we can check, is there a connection between 1 and 2? Yes, it is. Then it will be 1. It will be 1 since we have undirected graph here. Then it automatically means that if we have connection between 1 and 2, there will also be connection between 2 and 1. Yeah. So it means that the matrix will have symmetry there. It will be symmetric matrix. So this is unweighted, undirected graph. When we talk about direct graphs, then the matrix may not be symmetric, and in this case that would mean that we may have the direction between 1 and 2, for example, but there's no edge between 2 and 1. And so from 2 to 1 there may be no way. And in this case that would be that from 1 to 2 we'll have 1, and from 2 to 1 we will have 0. Okay? This case is possible in a directed graph. And the last case is the weighted graph. Weighted means that for each edge there will be one specific number, one specific number which will basically represent the weight. And then that will be not just simply zeros and ones, but instead of ones we may have the weight. Weight may be positive, it can also be negative. It depends on the task what the task is. And when we have such graphs, then we usually, in practice, such graphs are used in project planning. They are used in the traffic planning, in some different optimization tasks. So for example, the traffic to represent, we may have different routes, different roads there, and then each route has the specific weight, and specific possible, let's say, maybe number of cars or something like that. A moment. So some kind of different capacity available there, and then we can also calculate maybe the best route using the corresponding capacity there. But so this is the way how we can represent the graph. We represent using the matrices and two-dimensional arrays. And this can also be done using the lists. This can also be done using the objects, and this is how I prefer doing it in case I need to represent the graphs. And in this case, again, we can write the graph as the object. So first of all, in this case, we would have the class graph, and then what we know for graph. For graph, we have the vertices and we have the edges. And at this point, we can define our own representation. How do we want to represent? For example, that would be that basically the way where the edges will be stored. For example, the edges can be stored inside the graph class, and in this case, actually for each edge, edges will also be the objects. And then for each edge we can define what are the vertices used there, and also the weights if needed. So this is how it will look like. So the number of the edges will be the sum of all degrees. So then again, as I said, we have two possible ways of data storages there. So the advantage of WIS would be that that's actually space efficient, since this will work similar way as the linked list works like. And again, the disadvantage there would be that the navigation in between the edges would be more complicated if we use the arrays. So yeah, then the matrix, agency matrix, what I just said, that would be just two-dimensional array. Then there is also the space complexity. So the space would take big O from number of edges or number of vertices in power of 2. So that means that if we add one more vertex, then it will increase the space quadratically. Yeah. 2, so that's not linear time, not linear space. For the time to list all vertices, that will take us that will take just simple number of big O from number of vertices, since we just simply have just for each vertex. The time to determine if we have matrix, then the time to determine if the edge belongs to the set of edges in graph. So basically we can check if edge belongs to graph. It will take constant time, since we just simply need to point to the one corresponding cell in the matrix. Yeah, so and here we can see the difference. So to insert a edge in the agency matrix, that will simply take one step, since we just simply need to change the value in the table. Simply need to change the value in the table, then it means that we'll add the edge there. To check if edge is there, then this will take constant time, since we just simply need to point to one exact index. Check if there are successors, then it will take maximum of number of vertices, since we will need to go through the columns and the rows there. So in the worst case, we will need to go through the whole row or the column. And if we talk about the agency list, then to insert the edge, it will take maximum the number of edges steps. Same is for to check the edge, since we'll need to go through all the edges. Check the successors again, also need to go through all the edges there, and same is for predecessors. What then can be used in C#? From C# perspective, we can use graphs from collections class, in a special collections class what we can use, and then there is the representation of edges, then from and to. And so here you can check how the representation looks like. And yeah, so what are the namespaces used for the collection? For the collections, so .NET framework in general provides several components that aid in using collections. So, and here we can check the namespaces. So there can be general namespace collections, what we already used. So this we can check what we used already. We used this class here. We used simple collections class. There we used the array list there, and also a generic class. Generic class. There we used linked list. So sometimes, yeah, please be careful which namespace do you use, because for some namespaces the corresponding collection may not be available. But yeah, so in simple collections namespace, there are no generic collection classes and interfaces used. Then it's specialized, there are strongly typed collections, for example linked list, direct dictionary, bit vector, and also that contain only strings. Then in generic, there are generic collection classes and interfaces. And in object model, there's different proxies and base classes. We will not cover them right now. yeah, flavors of collections. So it's covering across these namespaces and components that provide standard interfaces for working with a broad range of collections, collection implementations. Yeah, so in general, we will work on such interfaces. Again, we did not talk about what are the interfaces and what are some kind of abstractions in C#. We will talk about these topics a little bit later. I'm just checking the that's interesting. We did not talk about the interfaces yet. And abstractions. One moment, let me check it. It's strange that I was expecting it will have it later, but okay, then this is what we will talk about. One moment. Okay. Yeah. So this is also the part of. This was also the part of your task. So yeah, this is what I will mention definitely. So I guess we need to start today. Unfortunately, I don't have the presentation about the interfaces and abstractions, but we also need to talk about the inheritance there. So let's then. It's strange that I don't have the presentation about it. This is really strange. Yeah, this is really strange. I don't have a presentation about the inheritance and abstract classes and abstractions. Let me double check. Do we have this? Okay. This is really strange. But okay. So, yeah, then since we started it, okay, maybe let's finish this presentation and then we'll go to the. We will start talking about the interfaces and also the inheritance. Actually, this is quite a large topic. I don't really like that we haven't had the presentation about it. But okay, I have some presentations, and we can talk about them tomorrow then. But okay, so then let's finish with the collections, and then we will move to the inheritance. So yeah, in general, the collections are, as I said, the interfaces which actually provide the implementations of different actual concrete implementations. So in general, list, this is some kind of just abstraction. In fact, there are array lists, linked lists, and so on. So yeah, in C# we need to distinguish generic and non-generic. So generic collection interfaces, these are the strong type safety and should almost never be preferred over the non-generic collection introduced in C#. So yeah. So for example, yes, we will. Maybe let's talk about them a little bit later. What are the generics and non-generics? But I guess right now I want to point your attention to the fact that what we used for array lists, as you can see, we did not provide the actual type of the collection. What we use in this case, in theory, we could add any object, any type object, whatever we wanted. Yeah. So we did not provide any type there. We could add whatever we want. comparing to the linked list where we actually provided the type of the elements to be added, to be used in this collection. And this is actually what is called generics in C#. Yeah, maybe tomorrow we will then definitely talk about the inheritance, about the abstractions, and yeah, also about the generics, because this is the topic what we definitely need to go through. Yeah, I'm not sure why it was missed in the planning of the course, but we definitely need to go through them. But yeah, so that's the idea. Again, in this case, the idea is quite simple. If we mention the corresponding object there, then it means that the type, what is used in the corresponding list, that we should this means that we should only add the officers there, and we cannot add any other object type. Yeah. So that's the point when we use the generic there. But some collections also may have just no type, and in that case it means that we can add any type there. Yeah. So that's the point. Yeah, what's the collection in general? That's the proper object which actually stores the set of the elements. Yeah, at minimum it needs to provide some mechanism to list or enumerate its members. So other useful but non-essential functionality might include adding and removing items there, querying the collection, indexing, and so on. So the enumeration, so that's the interface. Again, I will explain what are the interfaces and what are the difference between the classes and the interfaces a little bit later. But in general, we should think about the interfaces in the way that they have the methods. They have the methods that can be used there. Like again, it means that if the interface is used, if the interface is provided, if the interface is provided, then it has the methods, which then should be used inside the collection. Yeah, so in .NET, the name of the interfaces should start at I. Yeah, that's why if you see the name starts at I, this should normally be the interface type. Yeah. So then there can be bad enumeration design. So yeah, at this point I don't like that we haven't talked about the inheritance. Okay, yeah, in this case that's maybe not really good. Yeah, so in this case, when we have the that's bad enumeration pattern, because here we actually use while. We use while, and in fact we also need to do the casting again. This is also the topic what I want to discuss. Unfortunately, we haven't had the presentation about it. This is what I don't like. So then I can actually then start using the examples. So at this point, maybe let's then pause this topic a bit, and I would like to then switch to the topic about the inheritance. And fortunately, it is also the part of your home task. It's the part of your home task. So then you'll go through it. But again, before you do it, then I would like to show you some examples about the inheritance. So just maybe let's pause on this presentation, and then we can actually go to the inheritance. So first, what the inheritance is. As I said at the beginning of the topic about object-oriented programming, we have the data abstraction. And we also have the pattern when we can describe one kind of object in more precise way. So, for example, let's say that we have the class phone. Yeah? So we know what the phones are. So in general, yeah, we can make phone calls from them. We can text the messages, and just all the general things what the phones can do. Yeah? So that's let's imagine the class of phones. Yeah? So we have the class of phones which has all these parameters, and it also has all the behavior definitions, all the methods which actually describe the phones. Yeah? So just imagine we have this class. But on the other hand, let's talk about the classes or the class of smartphones. So let's say that we have the class smartphone. So in this case, we know that all the smartphones are the phones as well. So in this case, we have the class smartphone, but we also have the class phone. So the question again here is, is there a relation between these two classes, between the class phone and the class smartphone? Yes, there are. There are definitely, and what's the relation there is? The thing is that we know what we know. That's also the point. That all the smartphones as the objects, they belong to the class smartphone, right? Right. That's correct. But what we also know that all the smartphones, they also belong to the class phone. Yeah. So we know that all the smartphones are the phones as well. Yeah. So in this case, we talk about the objects. I mean, the physical objects, just the smartphones everyone has. And in this case, we can actually direct them to both classes. We can direct them to the class smartphone, and we can also direct them to the class phone. So in this case, first thing what we know, that one object actually belongs to both classes. So in theory, this may be a little bit confusing, right? Since we have one object which belongs to both classes. But again, from the real life, this is not something confusing, right? So just again, imagine, smartphone, is it phone? Well, we have the class of phones, that's correct. And smartphones also belong to this class. The class of phones, yes, as well. Smartphones belong to the class of smartphones, and they also belong to the class of phones. Again, right now, based on what we talked before, that's maybe a little bit confusing, right? Since we all know that one object may belong to one class. So in this case, how can we proceed there? In fact, this is what the inheritance is about. In practice, we can define such a case. We can define the case when one class is inherited from another class. So in this case, what I just said, which class is inherited from, we have class smartphone and we have the class phone. So which class is inherited from which class? So can you answer this question? Yeah, that's correct, Win. That's absolutely correct. And this is what the inheritance is about. Please remember, so every time, again, we will talk about the syntax, we will talk about the properties. So some things may be complicated. Don't worry, that's the syntax. All the syntax may be different in different languages. Usually the syntax cases, this is not what you should really worry about. First thing, what you should, every time we talk about the objects, you write some kind of logic, what you should understand, if this is object-oriented programming. And when you develop the classes, then the first thing what you should understand is that one particular object, it can be part of two classes. And in such case, the classes can also be inherited. Like if we have smartphone, this should be inherited from phone class. So in this case we have two classes, but smartphone is actually, it is actually the subclass of class phone. Yeah, and in this case, all the, as I just said, all the smartphones will be also the phones as well. So what does it mean? It means that smartphone will inherit. Now what does it mean that smartphone class inherit the class phone? It means that all the properties, all the definitions from the class phone will be inherited in the class phone. So it means that you have the attributes like maybe serial number. So that will be the attribute serial number. Then you may have the attribute just maybe some technical properties, so we'll not cover them. But then you can have the method which say maybe make a phone call. So that's the method which will be defined in the class phone. But then the question is, if we have the class smartphone, why do we need to define all these methods which are actually defined in the class phone? So why do I need to define all these methods? Why do I need to define all these attributes which all then are the same in the class phone and smartphone? So in fact, I don't need to do it. So what I can do, I can just simply define all the attributes in the class phone, then define phone as the superclass. Yeah, we have such terms like superclass and subclass. So in the case I just mentioned, smartphone will be a subclass of the class phone, and then the phone will be the superclass of the class smartphone. And this is also the case. Yeah, so every time, as I mentioned, the syntax is important in every programming language. But the thing what you should firstly think about is that we have this top-down design pattern. So it means, again, the key thing is that we go from top to down. Yeah? So it means that we have some kind of all the superclasses will go to the top, and then to the down we may have, when we go down, it means that we inherit the properties from top. Then all these properties will also go to the classes which are defined down. Yeah, and this is the case. So maybe let's have 10 minutes break now, and then we will continue then talking about the inheritance. Okay, so let's continue. Let's continue, and so just for you to make it more clear, let's create one example. Let's create one example. Let me create a folder here. So let's say that we have folder. Oh, that's under. Let's add it under object-oriented programming. Folder, and that would be inheritance. Okay. So let's create then a new project there. Okay, so and then let's start. So let's start with the class person. Start with the class person. So let's create a class person and yeah, so for each person, let's say we have name and surname. Name and surname. and let's maybe also create date of birth. Okay, maybe let's yeah, let's create date of birth. So we can use the classes we have. Also, we can create a separate class, which will then store date of birth or the structure. Maybe let's keep date of birth right now, just not overcomplicated. So, and then let's create getters and setters for them. So in theory I can create get. This will return value. Hold on. Just let's quickly double check how do we use getters and setters there. There's oh no, sorry, return. Oh, so that was the setter. So return the name. The name. Oh no, sorry, that's the thing. Okay, then let's just simply use classical. I prefer classical, right? So that would be what we have. Public string get name. Return the name. And then also let's do the same for surname. I will not create setters because we'll just simply can use approach of using constructor there. So then this would be just the normal way is that we usually define the constructors on the top. So that would be public person, and here we can pass name and surname. And then assign the values. moment. So nothing special here, just the object person, which has name and surname. Okay. So, but let's say that now we want to create the class employee, and just to show the details what employees can do. So then for this purpose I will need to create another class. Let's create the class employee. And what do we know? We know that all the persons or all the employees, they are humans, they are persons. So in this case I'll need to create the class employee, and now I want to point that this is that employee is a person as well. So in this case the syntax looks the following way. I use column and I point the class from where I want to inherit. Yeah, so in this case I say that person, class person, class employee is inherited from the class person. So what does it mean? It means that the class employee will have all the properties that the class person has. Yeah. Except one thing. So here you can see that we defined actually it will have, but it won't have the access to these attributes, the direct access. Why? Because they are defined as private. So in this case from this class, like let's say let's maybe add the method, the attribute, additional attribute that will be private. Let's say private double, let's say that would be salary. Salary. And let's also create getter. Salary. So in this case, in fact, we'll have the same properties what the class person has. Yeah. So how this would work? How this will work? Yeah. One thing here, we cannot set salary from outside class. So in this case, what I can do, let's do some different approaches. Let's try that one first. First, let's set salary. Salary, and here I can set salary, and then salary will be, so 1 moment, just one quick thing to clarify. Yeah. No moment. Yep. Just forgot to mention that. Yeah, we should normally define them in lowercase. Methods to be defined in uppercase, however the attributes we normally define them in lowercase. Just of course the variables as well. Just let's match the cases. That's not so important, but that's better if we follow the rules there. Okay, so, and now let's then do it. Okay, at this point, I guess we'll have the error. Let's try to run the program. We have error. Yeah. Oh, 1 moment, person. That is because yeah, that's employee class. Yeah, that's the point. Here we have one block, and this is related to constructor. So what's the just from your point of view? From your point of view, just again, if we talk about the case that we have the object employee, we have the object person. And again, we know that all the employees are the persons. In this case, we define the constructor. Yeah, we define the constructor, and here we say that we can. Yeah, what we say here, we say that we cannot create the object person without name and surname. And if you take a look on how we defined the class person and how we define the class employee, what's the issue you may see here? From what I just said, all the persons all the persons must have name and surname. Without it, we cannot create the object. And we say that all the employees are also the persons. So what is the issue you may see in the definition here? Yeah, remember that employee, that's the class. That's the class what we can use the same way as all the classes. But what's the issue here? You may maybe notice. Let's see here. An employee can be created as all the almost correct. That's the thing. Again, remember that all the properties are inherited from the class employee. But the thing is that, yeah, that's almost correct. But the thing is that constructors are also inherited. Yeah, so constructors are also not actually inherited, but they are kind of inherited. The thing is that, yeah, here we have the thing that we must provide name and surname to create the class person. Yeah, but in this case we create the class employee, the object employee, to create the person, the object person, but here we create the object employee. So in this case, the thing is that we don't have the constructor. We don't have the constructor which has name and surname. Yeah, because okay, yeah, to be more precise, constructors are not inherited. But this means that we should call them directly from the subclasses, because the idea is that if we have unparameterized constructor, then that's easy. It will just simply be called without any issues. But for the parameterized constructors, like we have here, we need to find a way how we pass the parameters to the constructor. So in this case, what we should do? In this case, we must create the constructor employee, where we pass the name and we pass surname. But this is not the end. We just simply now created the constructor, but we need to pass these values then to the name and surname, which are the part of the person class. So in this case, in this case, I'm just switching between different languages, and that's why I'm and that's why I'm getting yeah, that's great. Yeah, sorry, just I'm just switching between the languages, so I'm sometimes forgetting the keywords. Yeah, of course, that's base. That's base because yeah, actually, from my experience, this keyword is used as base, as that, as super. But yeah, so that's base. So base means that we can just simply access the object from the superclass. And in this case, I can access constructor from the base class. And let's see if the error disappears now. Okay. One moment. One moment. Oh yeah, sorry, that's already moved. Yeah, I just forgot. No, I just need to move it this way. So this will go that way. So, and now that should be correct. Oh, hold on. Without the semicolon here. So this is actually the way that you, in this case, the program is compiled. Yeah, so that's the way. So here we must call the parameterized constructor from the super class, which is actually base class. Then we can call the class super, we can call the class base, but that's the point. Yeah? That's the point, again, because we cannot create the person without name and surname. And this is what we say now. If employee is the person, which is what we defined here, we cannot create employee without name and surname. But here we have this constructor. So we can simply call the constructor from the base class, from the super class, by providing the parameters here. Yeah. So in this case, it means that we can call the constructor employee by providing name and surname, and it will call the object from here. Actually, here we have no object. We can then make it more interesting. We can provide the salary here, and then salary here. And so in this case, we call the constructor from the super class. So this logic is called, and in addition to this logic, we also call this logic. Yeah. So, and now let's test what happens there. So, how this will look now. Here I define the variable employee. And here I create employee. Yeah, so here I need to provide name. So let's say that name would be maybe Jack Sparrow. Sure, and the salary. Here we need to provide a salary. Let's just provide some kind of salary without mentioning the currency. Yeah. So here we created the employee. We created the employee with the name Jack and surname Sparrow. That's correct. That's correct, and you can see now what we will see. We can see that for this object, for this variable, we can access the methods defined in the class person. Yeah. So here I can really print out right line name of employee is. And here I can access the name. So name, I will simply call the method get employee, get name. So, and then the same is here. The surname of employee is employee get surname. Okay. So what do we see here again? What I just said. That is what is called abstraction. Yeah, in this case, we see that the class employee, if I go again, I go to class employee, I don't see these methods. I don't see the method get name and get surname. I don't see them here, right? So kind of magic, but in fact, these methods are defined in the superclass. So basically, this is what the inheritance is about. Actually, these methods are inherited. In fact, so here I would like to pay your attention that everything is inherited. Everything, including the private methods and private attributes. So what does it mean? It means, again, private means the access. We cannot directly if they are private, we cannot directly access them from the subclass. Yeah? We cannot access, right? If I want to write the logic here, I cannot point to this name. Name is not accessible from here because this is private. Yeah? Maybe I can say this. Okay. This name equals name. And I will mention that this is not correct because name is privately defined in person class. Yeah? So we cannot access because it's private. However, it does not mean that it is not inherited. Even the private attributes are inherited. So in fact, they are also the part of employee. They are not accessible, but they are still the part. And this is what we can simply see here. Employee does not have these attributes defined here. They are private. They are privately defined in this class, but they are still stored under employee object. Yeah, employee still has these attributes. That's because they all come from person class. Yeah. So that's the thing. These attributes are inherited. And regarding the constructors, they are kind of inherited, but we still need to access them. Yeah. And if constructors are parameterized, technically it means that the objects can be created only with these parameters provided. However, since we have the subclass, we have these parameters, they are parameterized, so it means that we need to do some kind of redirection to the constructor of the superclass to then provide these parameters. Otherwise, without providing these parameters, we cannot create the object. So, and let's test the logic. Simply show you that it works. Yeah, so here you can see that everything works. So far, do you have any questions? Okay, no questions. And here I want to add one small adjustment. Oh, okay, I see the questions are coming. Yeah, sure. This may be a little bit tricky topic, especially for the beginners, but this is how the concept looks like. Okay, just any questions if you're not sure about how. I mean, the tricky thing is the constructor. I agree with you, but in this case, need to be careful. Just simply, if you have parameterized constructor, that from all the subclasses, you must define the redirection to this constructor. That's kind of one tricky point. You must define the redirection. So, and no, yeah, good question. So just to change the salary, then we need to, and yeah, also let's add the salary here, and also the salary of employee is, then I say employee get salary. Yeah, so here we'll also print the salary, and then I can ask user to enter new salary. So what's new salary of so here I can input name and surname. Surname. So here I can change the salary. I can ask user to write salary. So here I can do our usual check while true. So it means that here I'll try parse if. So then I'll parse. Try parse. Then I'll ask user for input, read one, and here I go, here I'll need to then read the offers. That would be then double, not integer, sorry, double, salary, let's say, so let's start with previous salary maybe. And so here I will read this new salary. Yeah. So if it's parsing correctly, then I set this new salary. So here I can change it. Yeah. So here I set it. Here I change it, and then I break this loop. Otherwise, I say that the input is not correct. So I usually prefer just using this check because this is how you should not complete. And so here again we use the same object. Yeah, we don't need to. We basically can proceed with inherited classes the same way as we proceed with the standard classes. Yeah. So and then I increase the salary, and then I can say that simply repeat this code, and let's see what happens. And so here you can see the salary, and let's say the new salary would be, let's say we increase the salary, so you can see that now the salary is changed. That's possible. That's possible. We don't need to change the object. I mean, we don't need to create the object from the beginning. What else we can do? First of all, yeah, just let's make one small adjustment. Yeah, do you have any questions about it? Yeah, the properties, the behavior of the subclasses is absolutely the same as the behavior of simple classes. Yeah, the only thing is that some additional attributes are added. Not attributes, additional methods and attributes are available from the superclass. Yeah. Basically everything is inherited, yeah, except one thing, that the constructors are not inherited. They are inherited, but we must access them. If the parameters are parameterized, then we should access them. If constructors are parameterized, we should access them. One thing, so here we can actually use the protected attribute for the first time. And here is the point. Here is the point for protected attribute. Let's start this person class. So here I can use protected attribute. And in this case, I can access this name. Yeah, it will be available now for this. Yeah. So now the only difference is that inside this class, so I can point, not correct, if the attribute name in the class person is defined as private, and now it is correct. if the attribute is defined as protected in the class person. Okay. So that's the actual point. That's the actual difference between private and protected. Yeah? You can access protected attributes from the subclass, and protected attributes and also protected methods. That is just the only difference. Yeah? From subclass you can access these attributes now. But again, the workaround, not around, but the way how you can also access them in another way would be that you as here we did it, and that you use public or protected methods then. Okay. So if you use public or protected methods, then like for example setter, you can access them attribute then also from any place you want. Yeah. So that's the point. That's the point. Do you have any questions so far about what we talked so far? Okay, so and also another thing what I want to then mention now is the calling of the yeah, actually the method, the overriding of the methods. So what does it mean? It means that let's imagine that you have different behavior. Defined in two classes. Like let's say that you have one method which has different logic in the subclass comparing to what the superclass has. So how can we proceed in this case? So remember, we already did similar thing to the method toString. So let's remember what did we do in the class is toOfficer, yeah? So remember that we overrided the method toString. Yeah, actually for all the objects we have the method toString defined. Yeah, because all the objects in C# can be represented using some kind of string. Yeah, so and that's why if we want to have specific logic for the method toString in our subclass, in our class, yeah, which is actually inherited from the object class, then we need to override this method. So it basically means that the class officer will have different implementation of the method toString, yeah, comparing to the original toString method. The same can be done for all the methods. So and then let's maybe start with the simple method toString, and then we can maybe next time tomorrow we will try the same for other methods. Yeah. So at this point let's override the method toString. Yeah. So in this case we can create our own representation of the method toString. So here I can say that the name is that I want this get name, yeah, plus UI plus surname is this get surname. So just simple redefinition of toString as we did before. But how can we proceed for the class employee? So what we know that employee will again have all the same values there, right? So not the values, but the same logic there. So it will have name and surname, right? So we can also add it to the representation of class employee. However, we also need to add one addition. We need to add the salary here. So how we can proceed in this case? In this case, we can do the method overriding. So there, again, please remember that two different terms, overriding and overloading. About the overloading we'll talk a little bit later, but actually we already did some things regarding the overloading, but for the overriding, we also did it for toString. But yeah, so what can we do here? We can override the method toString, and then it will then write the logic for it. In addition, what we can do, we can also like override the method and then use the existing logic and add something more from us. So basically this is what happened here. Yeah, here we created our own constructor. We called the logic from the superclass. Yeah, so in this case the constructor from the superclass will be called again. Base means superclass, so it goes to the superclass right here, and then this constructor will be called. Yeah, using base we provide the parameters, then these parameters will be passed to this constructor and it will be called. Yeah, this logic will be called. And then here we add the addition from our side. The same can be done for toString, but using different syntax of it. So here again we can override string toString. Yeah, so in this case, if I keep this logic, what will happen? In this case, simply the logic from the superclass will be called. Yeah, this logic will be called. If I write base toString, yeah, so I can even press Ctrl, then click to navigate me to this method. But in addition, what can I do? I can put some additional code. So excuse me, that write the comment. The methods toString will be called from the class person, and here we can add additional logic, and additional logic would be new line and say that salary is, and here we can get the salary. We can access it this way or call the method, no difference. Yeah. So in this case, I add additional logic to the logic created before. In theory, I can also override it totally. Then this will have a new logic. But I can add more. And yeah, so let's see how can we use it. So here I can write. Yeah, so I can print the person, and let's see how it will look like. So let's change the salary here, and yeah. So here you can see how this is this line. Yeah. So now we can see that I print the object employee. And what basically happened here, actually here this method is called, and this method first it calls the method base toString, so it goes to the base class, to the superclass, and calls this method. Yeah, so it gets this value. In addition, it also prints this value. So this is a good example to understand the most usual purpose of the subclasses. Yeah, and as I said, the most usual purpose is that we do the inheritance. So it means that, just remember, this sentence is quite important, that for the subclasses, we add more features comparing to the superclasses. Yeah. So the subclass is practically the same superclass plus something more. And it's a very important case. It cannot have less than superclass. Yeah, we can add more, but usually how it happens, we cannot reduce something. So that's the point. And here you can see the direct representation. We call the same thing that the superclass has. However, we also add a little bit more. Right? Okay. Do you have any questions? So if you have any questions, then we can also prepare maybe for tomorrow's session. We can discuss them there. And let me also then print the, no, not print, but push the changes now. Okay. Git add, git net 16. Okay, so I guess for today then we can finish. If you have any questions, please prepare them. We can discuss them tomorrow. So thank you very much for your attention. And then let's continue tomorrow. Bye.